Hello everyone, this is Ravina. Welcome back to Pseudocoder. Today we are going to solve the number of islands problem. This one is very popular with Amazon, Microsoft, Google, Bloomberg, and many other companies. That is because this example actually tests the candidate's depth first search and breadth first search knowledge. So if you are new to algorithm and data structures and you want to learn depth first search and breadth first search, I already have a video that I'm going to link in the description below. Please watch that video so that you get an idea of what we are doing in this problem. Let's start with reading the question here. So it says that given an m into n 2D binary grid, which represents the map of ones, which is land, and zeros, water, return the number of islands. An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all four edges of the grid are all surrounded by water. So let's first understand what the question is. Okay, let's take this example. The first example right here. We see that it's saying that we have to find an island in the grid. An island is basically adjacent lands connected together, either horizontally or vertically. So let's see. One is land, right? So let's start by looking at this first example. This is land, okay. Let's look at its adjacent sides, horizontally and vertically. Let's look at horizontal first. Let's see. On the right, it's 1. So, okay, it's one land is connected to the other land. Okay, fine. Now let's look at the right again. Okay, it's again 1. We go to the right again, we see another land, yes. We go to the right, we see water. 0 is represented by water. So we know that up till here we have land. Now let's look at the vertical part. For this one, vertically, if you look at vertical side, you see, oh, we found a land. Now again vertically, yes, we found another land. Go vertical again, we found water. So we stop here. Now let's look at horizontal for this one. You'll see, you find one other land, yes. Then this is part of the island. We go to the right, we find 0. That means we stop here. It's now it's water. Now this one has the horizontal one unexplored. So we go here, we find, okay, we found land. Now we go to the right, we see, okay, there's water here. If we go down, we find land again. So if you look at this particular example, all these ones are actually connected together. So if I go in and highlight this, oops, sorry, I missed this one. If you go down, you find another line here. So if you consider this whole thing, it's connected by all ones either vertically or horizontally. That means this becomes one island. In this particular example, do you see any other ones here? No. So the answer to this will be the number of islands for this particular grid is 1. Now let's move on to the next example. We start with 1. We find another one here. Yes. We find another one which is vertically connected. Other one vertically connected to this one. Now let's look at this. This is not vertically connected to this particular one. This is diagonally connected. And we are only looking for islands that are either vertically or horizontally connected. So that makes this as one island. If you look at this one, it doesn't have any vertical or adjacent ones, which is land. So we make this as another island. And going to this particular one, we see that these two are horizontally connected and there are no other vertically connected islands. So this becomes one island. Anything which is out of the bounds, so anything here, 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 or here is water. That's what it says. You can assume all the 4 edges of the grid are all surrounded by water. So means that everything outside the bounds of the grid is water. So this makes it this as another island. So let's count the number of islands in this grid. 1, 2, 3. So the answer to this is 3. So this is what the problem is. Now we can solve this using depth first search. Now what happens in depth first search is you get one element and then you explore all the elements going to the end of the going till the end of a condition. Okay, so let's look at the second example, this example, and let's see how we can solve this with depth first search. Okay, so we have this matrix. What we are going to do is initially we will be initializing a count variable. So let's see this. So count variable would be initially initialized to 0. So basically we start with the first element, we perform DFS on it. Before performing DFS on it, we want to make sure that every element that we visit, we mark it as visited so that we know in the future that we don't go in loops and we don't explore the element which is already explored. So to do that, what I'm going to do is I'm going to change it and make this as 2. 0 represents water, 1 represents land. And that's all the matrix is going to be. So to mark it as visited, what I can do is I can mark it as anything. I can mark it as 2, 3, 5, whichever number you want. I'm choosing 2. So whenever I start with an element, I mark it as visited, which is 2. What I do is I want to check, I'm going to explore its adjacent neighbors. So I'm going to look at the right hand side. Oh, I find 1 again. If it's 1, what I'm going to do is I'm going to again make it as visited. So this particular element is visited and then perform DFS on it. I go on the right, I check, okay, this is water. So I bounce back to my 2. Since I explored the right hand side, the next thing I'm going to do is explore downwards. I find 1 again. I mark it as visited and then explore this 2. I go on the right hand side, I find water, bounce back. I'm gonna go down, I found water, bounce back. I go to the left, I find another land. I mark it as visited, come back to my original position, which is 2, and then I explore the upside, which is already visited, so I come back to my 2. I go back to my 2 here. I've explored its right down. Now let's see what's up. It's out of bounds. So I come back and then I go back to my left and then come back to my original position. When I come back to my original position, what I'm going to do is I'm going to increment my count. So I'm going to increment my count as 1 because I have explored everything, every piece of land that is in my adjacent vertical or horizontally. So I'm going to increase my count to 1 and mark this as an island. The next part I'm going to do is I'm going to keep exploring my grid. I explored this first. Time for this. Is it a land? No. I'll move forward. Come to 0. Is this a land? No. Forward. Is this a land? No. Land? No. Land? No. No. Come here. Is it this a land? No. 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 Then I reach here. Is this a land? Yes. What I'm going to do is mark this as visited and then perform DFS. Performing DFS would be go to the right, see if you find more land. No, you did not find anything. Come back, explore down. It's not a land, it's water. Go left and go up. We did not find anything. We found just one thing. So we came back to our original position. We mark our count as 2 and mark this as an island. Okay, so we are gonna explore other elements now. Same as before. We come here, it's 0, it's not 1, not 1, not 1, not 1. We come here, it's 1. So I'm gonna mark it as visited, perform DFS on it. Go to the right, found 1, mark this as visited. Go to the right, there's nothing, come back. Go down, there's nothing, come back. Go up, it's 0, come back. Go to the left. come back to the position, go down, there's nothing, come back. Go to the left, it's 0, come back. Go above, it's nothing, come back. We came back to the same position. Once we come back there, we are going to increment our count to 3. That makes this as another island. So we mark it as another island. And in the end, what we do is we return our count. So we return 3. And that's what our answer is. Look at how we solved this particular example. We found answer 3, and that's what we got this time, 3. Now, let's write some code and see how we can do this in our code. For that, this is our method. The first base condition that I want to do is check if my grid is not empty. If I have an empty grid, so suppose if I have grid like this, there's nothing inside it, that means the number of islands would be 0, right? Because there's nothing in it. So that would be my first condition. My first condition would be if length of grid is equal to 0, then you simply return 0. My second step would be to initialize my count. So I'm going to initialize my count to 0. Now I need to write for loop for my 2D matrix so that I can explore each and every element. So I can do that using for I in range length of grid, for j in range length of grid of 0. If so, I am at my element now. What I want to check is if that is a land. That's what we did in the example. So I'm going to check if my grid of I, j, is equal to 1. If it's 1, then I want to perform my depth first search. So I'm gonna define my depth first search as a mark island method. What I'm gonna do is I'm gonna pass in the grid, my ij, and my m and m. I mean what my grid length is. So it would be length of grid, and this would be length of grid of 0. Once I come back to my original position, that's when this method is going to return back. At that point, what I want to do is I want to increment my count. So I'm going to count equal to count plus 1, and in the end, I want to return count. Now let's write our DFS function. DFS function is really easy to write because we know how to process this. So let's start. I'm making a function mark island. I'm getting a grid I, j, m, and n. The first thing that I want to do is to check if the I and j that I got is out of bounds. That is right here. That scenario comes when you are here and suppose you are here. You want to explore the right hand side. That's when you will pass in I, which is out of bounds. So sorry, j, which is I, which is out of bounds. So you want to make sure that you return back to our original position, which is 2, and not explore this particular element because it does not exist. So what I'm going to do is I'm going to write a return condition where when x is less than 0, that means x is negative, or if y is 0, or x is greater than equal to m, or my y is greater than equal to n. If these conditions are true, that means it is out of bounds. There is one additional condition that I want to check. When I perform DFS on a particular function, I also want to check if it's not already visited. And if it's a land, then and only then I want to perform a DFS function on it. So I'm going to check or my grid of I and my grid of j is not equal to 1. Now there's a small mistake that I did. I took an I and j and I wrote x and y. So let me correct that. This should be I, this should be j, this should be I, and this should be j. Sorry about that. If these conditions are true, I simply want to return. I want to go back to my previous position. That's all. Now, when we perform DFS on a particular function, what do we do first? First, we mark it as visited. In our case, we were marking it as 2. So what I'm going to do is grid of I and j will be marked as 2. And then we perform DFS on that particular element. So we do mark of island, we pass in the grid, we pass in I. To go to the right, it would be j plus 1, m, n. So let's take this example here. I'll say 0, 1, 1, 0, and these are our indexes 0, 1, 0, 1. This will be I and j. Okay. If I'm here and I want to explore the next element, which is on the right, I will be incrementing my j. My j will be incremented from 0 to 1. So it will be j plus 1. If I want to go downwards, that means that my I is going to be incremented. So my I will be I plus 1, right? So this is how you see how you want to go right, left, up, and down. So that's what I'm doing. I'm doing j plus 1, which is going to the right. Now let's go to the left. My going to the left will be really simple. I'm just going to do j minus 1. That's going to be my left. Up would be I plus 1. My j will stay the same, only my I will change. And then the last would be I minus 1. This is basically moving in all directions. So this is the code. What we did is first we checked if the grid is empty. If it's empty, return 0. Then we initialize the count. Then we are processing every element in the grid. If it is 1, we are performing DFS on it. And once it comes back to its original position, we increment the count. We do that for all the elements, and we then return the count. In our DFS function, we are checking if our indexes are out of bounds, or if the element is not equal to 1. That means it's not a land. If any of these is true, then we just return. If it's not true, then we mark that particular land as visited, and then we perform DFS on it in all the 4 directions, vertically and horizontally. Let's try and submit this one. Okay, let's see. I have a syntax error here. Yes, you are correct. This should be minus. Let me try and then submit again. Okay, I see it. This should be in inverted comma because it's a string. My bad. Now let's try and submit it. Okay, it's accepted. The time complexity of this algorithm would be m into n, because we are exploring each and every element in the grid, and the grid is m into n size. The space complexity, however, would also be m into n, because there can happen an instance where this particular grid is marked with all ones, which is all lands. So that makes our space complexity as m into n. This code is gonna be on my GitHub channel, and I'll be including the GitHub link in the description below. I'm also now on Discord, and you will find that link below as well. Please join my Discord if you have any questions or you want to just talk, connect. We can do that. And hit the like button if you like my videos and subscribe so that you can see get notified about new videos coming up. Thank you so much. Happy coding.